Hi everyone. So I've got a new version of Telemetry Viewer that I'm ready to release, and in this video I'm going to show the new features. So like in my earlier videos, I have this little balancing robot demo so that I can kind of show you how the software works. And so if you haven't seen it before, it's this little like Segway robot that'll balance on its own. And I have a remote control for controlling it. Alright, let's start by taking a look at the new features in this version. I've got about 6 or 7 significant changes, and perhaps the most commonly requested one is time on the x-axis of charts, which I want as well. So I actually added that feature. So now when you create or configure a chart in the duration area for the like the time domain chart, like these kinds of charts, you can specify it by samples, which is what we have here, about 1,000 samples, or you can specify an amount of time. And so, like right now, 1,000 samples is basically 13.7 seconds with my robot, the way it's set up. And so we can see here we now have time elapsed on the x-axis, and so we have minutes, seconds, and milliseconds shown there. So right now it's only showing time elapsed. I don't have it yet set up to where it can show the date and time, but I do plan to support that probably in the next version or sometime soon. But it's been such a long time since the previous version, I thought I would release what I have so you guys can benefit from it, and I'll just continue to make improvements as I have time. Another kind of small thing, which is kind of obvious now, is when you create a chart or configure a chart, it will use this panel on the left-hand side of the screen, instead of popping up a window that kind of gets in your way and obscures the charts. So that's a minor thing, but something kind of nice. So for example, if I were to create a chart by clicking and dragging, instead of popping up a window, it'll show this. And so I can go to accelerometer data, and I click done to make this panel go away. Also, to make it easy to very quickly set up your charts. In fact, I'll show you like this. You just click and drag to make a chart, choose what you want. You don't actually have to click done. You can just go ahead and create another chart. And so you can repeat that for all your charts. So clicking done is optional. It's a minor thing. Often I use this software to help me debug some firmware, and so it's just nice to have one less annoyance. You don't have a pop-up window that's obscuring your view. You don't have to click done. Just, make it easy. As I mentioned before, we can show time on the x-axis of these charts, and that also means that we're recording the timestamps for every sample. And now if you export a CSV log, it will actually save those timestamps. So it will save the Unix timestamp, so it's like a number of milliseconds since the year 1970. So you can use Excel to convert that into a human readable form if you want, but I leave it in the Unix timestamp format because it's more efficient for the software when it's doing the charts and everything. But that is a feature that a lot of people have asked for, so I've added that to the exporting of CSVs. So for example, I can do that right now. We'll create big log, and it saved it to my desktop. So now I have the file, and if we open it in Notepad, we can see we have the first column is your sample number, the second column is the timestamp. So in this case, these are timestamps. One thing to keep in mind is a Unix timestamp is a number of milliseconds, which means your resolution is milliseconds. Now that's perfectly fine because, for example, with a USB UART, you can never get better than 1 millisecond resolution because USB is pulled at 1 kilohertz. Well, at least USB 2. One thing to keep in mind is if you're sending telemetry very quickly, like if you're sending, I don't know, like 10,000 packets a second, then the timestamps will clump together because it just depends on whenever the driver processes the data. So I wouldn't recommend using time here for the duration if you're sending telemetry very quickly. But it works fine for, tens or hundreds of samples per second. One thing that I wanted to do is be able to replay log files, and you can now do that. So if you go to import CSV log, I can go to log, open, and it will now import the file. And by default, it will play it back in real time. So this is me turning on the robot, and then I picked it up, and you can kind of see the graphs accordingly. If you just want it to finish importing the file and you're going to scroll through it later to figure out, or to find events or whatever interesting data you're looking for, you can click Finish in the bottom right corner. It will import the file as quickly as your CPU can keep up, and then it will finish. So now we're at the end, and you can use the scroll wheel to rewind and look for events. You can import CSV log files, which is a very useful feature if you're trying to debug data, especially like if you've acquired data overnight or over a weekend. You want to be able to save it and look through it later. Instead of clicking on the import CSV log file, you can now drag and drop. So I could have just done that, and you get the same thing. You can click Finish, and it will import everything, and you're done. You can do the same thing with layout files. So for example, I have my balancing robot layout file here, and I can just drag and drop. We'll wait for the Bluetooth UART to connect, and there we go. Now it's connected. We're back to seeing live data. So I can pick up the robot, and you can kind of see it respond accordingly. So as you can see here, we have these weird-looking markers, and that is the next feature that I have added. So let me explain that, because that probably looks kind of funny. Oftentimes, when you are trying to debug a problem, you might want to send the current state of your firmware in the telemetry. So you might want to send a bunch of booleans or enums, enumerations, to indicate the state of your firmware. And I wanted to be able to visualize that to help me find problems with stuff that I'm developing. And so I added a feature to the binary mode. It only works in binary mode, not in like the CSV text mode. But in binary mode, I decided to call it bitfields, but that may not be the best name for it. But I can see you can have a struct, and it can be a packed struct where you can specify how many bits are used to store each element of the struct. And so it supports 8-bit packed structs that you can define as either booleans or enums, and then it will show you events on your charts when those booleans or enums change. So in this balancing robot, I have only 2 boolean values that I'm showing as bitfields. One of them is I indicate if the robot thinks that it fell over, because if it thinks that it fell over, it will stop powering the motors because it cannot recover. So I have that as a flag. And I also have a flag to indicate integral windup. So with the PID control loop, the integral part can obviously integrate to a very large value if you have a constant error. And you often want to configure your control loop to limit that so it doesn't just grow infinitely. So I'm going to go ahead and kind of show how this works. So if I pick up the robot, if I just pick it up and then flip it on its back, we see a couple flags. So let me rewind. We'll pause time, and I'll zoom in by holding down Control and then scroll so we can kind of see a little better. Okay, so in my case, I have the firmware set up so that when the integral like accumulator, whatever you want to call it, reaches either plus or minus 1000, it defines that as the integral windup like limit, and it clips to that value. And so we can see here we have a marker at sample 9791 when the integral value reached negative 1000. And we can see here at sample 9796 that it decided that the robot fell over, and that was when it turned off the motors because it cannot recover from that. And so that's kind of what the bitfields do. It will pop up these like tooltips whenever your boolean or enum changes value. And then if you just want to see the current value, the tooltip right here at the mouse will show you the 8-bit number in binary notation. If I zoom back out and then go back to the end, so we get back to a live There we go. We're back to a live view. If I now pick up the robot, we'll see that it will detect that, and it will also detect that the integral windup goes away. So now the robot is balancing again, and we can see that it detected that the motor is, or that the robot is now upright, so it'll power the motors, and it detected that the integral accumulator, or whatever it's called, is no longer at its limit, and it has flagged that here. So this particular robot only has those two flags because it's a very simple control loop, but bitfields are really useful in more complicated systems, but this is the only one that I can publicly share right now. Anyway, you get the idea. I will show you how to define the bitfields in a little bit later on in this video. So as far as other features that may be kind of interesting, so a small one is you can now maximize a chart. So we have the close button here, we also have the maximize button now. And so you can maximize or demaximize the chart by clicking that, and it's a nice smooth animation. Simple, but kind of useful, especially like if you want to be across the room and you want to monitor your telemetry. You can maximize the screen, and you can hold down Shift and scroll to make the text bigger and the lines thicker, and there you go. So that's just a small little feature that I found really helpful. Something that won't be very obvious in this demo, but will be if you use the software a lot. In previous versions, if you had acquired a very large number of samples, like hundreds of thousands or millions, the time domain chart, like these charts right here on the left, if you were to zoom in, you would see these weird artifacts where data would clump together and kind of be offset a little bit. And that was because before I assigned the x value as, or I saved the x value in the chart as a floating point number, and of course when floating point numbers get big they lose precision, and if you zoom in you see that loss in precision, and that was a bad way to do it, of course. So I went back and redid how that works, and now the data should look good even if you have hundreds of millions of samples. That was a minor thing, but it would only be noticeable if you had very, very large numbers of samples acquired, and if you zoomed in to see them up close, where the x values would be very noticeable. Also on a similar topic, before all of the samples were stored in memory, so that meant that you were limited by how much memory you had. So now I added the ability to swap data to disk if you're running out of memory. It's all automatic, it happens in the background, but I've run my software, for example, over a weekend and had it acquire I think close to 200 million samples, and and it worked fine. It saved them all to disk, it could draw them on screen live, no delay, and it just performed very well. So there were modifications for that, and also modifications to kind of better support very large sample numbers. I plan to further improve that because right now the sample number is stored as a 32-bit number, and I'd like to bump that up to a 64-bit number just so that we can acquire even more data, but that's not yet ready. A minor thing was in the binary mode, I also added support for 8-bit numbers, so an 8-bit unsigned integer. Just a minor thing, but I needed that for a project, so there is now that feature. Okay, so that's basically all of the new features. I'll go ahead and open up a new instance. So just for testing purposes, I'll go ahead and say TCP, and I'll go ahead and show the binary stuff because I haven't shown that in a video before. So if I click connect, the first time you do it, Windows might ask you if you want to allow the software to run the TCP or UDP server, and so you need to allow that if you want it to work. And so here in this window is where we define the data structure. And so in the binary mode, basically you specify what byte number a value starts at. So the first byte is currently required to be a sync word, and it needs to be hex AA. And so in this case, the next byte, at byte number 1, we can specify whatever we want. So we have an unsigned 16-bit integer, we have a 32-bit float, we have an unsigned 8-bit integer, or we have bit fields. I plan to add a full set of possible data values here, but for right now, that's what I have because those are the ones that I have tested. So I don't want to add features that I don't test. So that's kind of why it's incomplete. But anyway, like for example, if you have a 16-bit unsigned integer, you give it a name, I don't know, call it temperature. You can give it a color. If you want, you can give it a unit. So we could do Celsius. Hopefully I spelled that right. You can do a conversion factor. So, well, with this you wouldn't really, but like say it was an ADC reading, you could say that 4095 is equal to I don't know, 3.3 volts. In this case, maybe we'd call that volts. Maybe we should call this something else. Let's just call it the battery voltage. Anyway, so that's probably a better example. And so you click add, and it will add that to your data structure. And so that was a 2-byte value. So then your next value could be at byte number 3 or later. You can have unused bytes. So if you want, you can jump to, I don't know, byte 5 or whatever. And I'll go ahead and demonstrate the bit field feature. So right now it is required to be an 8-bit number. I do plan to add support for 16 or 32-bit bit fields. But for now, this is what I had a need for, so that's what I implemented. You can give it a name, so I'm going to go ahead and call it flags. And again, you can pick a color. There's no unit or conversion factor because it doesn't really make sense for boolean or enum values. And, and then you click add. And so this is kind of the new thing. So it's an 8-bit number, and we have the bits up here. And basically you need to define what each bit means. So let's say I have a boolean value that is at bit 0. If I click and let go, I have now added a 1-bit bit field. And so you can give it a name, and let's say when that bit is false, which would be 0. In this case, let's see, for the balancing robot I had, let's say I think it was, what did I call it, upright? And fell over. You could call false to be the upright state and true to be the fell over state. And then for bit 1, I think I had the integral windup. And so in this case, I could say integral OK and integral windup. You can also have, of course, enums, which could be more than 1 bit. So if you have like a 2-bit enum, you just click and drag and let go. And then you have your 4 possible states. You can give them names, and so on. And when you're done defining all of your bits, and again, just like with other things, you don't have to use every bit, and you can have empty bits that you're, it can be sparse or whatever you want to call it, where you don't use every bit. Anyway, I'll just go ahead and call this A, B, C, D, and then click done. And then now you can go ahead and add other things. You can add another bit field. You can add other values. There is an optional checksum if you want, where it's a 16-bit checksum of all the bytes after the sync word. Anyway, and then you can click done. And in this case, I did it as a TCP. And so we can see here that the TCP server is running. And then you can send telemetry. And it will show probably multiple IP addresses here. Basically, it doesn't know what network interface you're going to send telemetry to. And so it will show you every IP address that is possible with your computer. And so like if you have Ethernet and Wi-Fi, you might have multiple addresses. And like I have VMware on a couple of my computers, and it will create these VMware adapters. It'll show like 4 or 5 IP addresses. So keep that in mind. Just you need to kind of think about which one is correct, but it will show you the possibilities. So I don't have anything sending data over TCP right now, so this isn't going to be drawing any data. But you get an idea of how that all works. In my previous videos, I've kind of shown how to do the telemetry in more detail. If you check out my older videos, I show you how to do everything in detail. One last thing I'll point out is, so if you click help, I have updated it to kind of reflect the new features. if you find the software useful, and if you'd like to, you can, like quote unquote, buy me a coffee or send a few dollars my way. So I set up a PayPal thing where you can do that if you like. It's completely optional. There's no like nag screens. I'm not going to commercialize the software or bug you about like donations or anything like that. But I do spend a lot of time developing this software, and if you do like it and if you want to, you can send a few dollars my way. But it's optional, and yeah, if you don't want to or if you can't, that's perfectly fine. So there will be links down below for both of these, and you can also click on the links through the software if you'd like. If you have any questions or comments, leave them down below, and if you know anybody that might benefit from this software or the video, please share a link with them.